Alright, welcome to my channel. Today we'll be covering a general introduction to macromolecules. So to start, we have some main concepts for the lesson. Macromolecules are polymers made up of monomers. Polymers are formed via condensation reactions or dehydration synthesis. Polymers are broken via hydrolysis. And there are four major classes of macromolecules: carbohydrates, lipids, proteins, and nucleic acids. So we'll start with macromolecules. What are they? The term macromolecule is synonymous with the term polymer. A polymer is a large and long molecule comprised of identical or similar building blocks linked by covalent bonds. The building blocks of polymers are called monomers. Below, I have some images that, at first glance, seem to have nothing to do with biology, but they're actually really helpful. So to the left, we have an assortment of beads: blue, red, green, orange, yellow, all jumbled up together. These are our monomers. To the right, we have bracelets. These are our polymers. The polymer is all the monomers linked together. This is a really helpful example to solidify the concept in your mind, as it can be rather confusing at first. So think of the beads as monomers and the bracelets as polymers. Polymers are comprised of monomers. So there are specific monomers for specific polymers, and monomers vary in composition. We're not going to get into too much detail on this today. I just wanted to bring it up as you might have some questions as I'm going through this and wondering why I didn't cover it, so I just decided to include it. So some examples: I have the polymer and the monomer. So carbohydrates have a monomer of monosaccharides. Lipids have a monomer of fatty acids and glycerol. And I'm sure you can see the asterisk next to lipids. That's because they're technically not polymers, and this will be discussed in depth in future videos. But for today, let's just think of them as this. And then proteins, their monomers are amino acids, and nucleic acids have nucleotides as their monomers. Also, it's important to note that the covalent bonds that link monomers together have special names, and they're dependent on the polymer it makes. So for example, bonds between monosaccharides are called glycosidic linkages, and bonds between amino acids are called peptide bonds. Glycosidic linkages and peptide bonds are covalent bonds, but oftentimes professors and teachers, they're going to want you to know what the specific covalent bond is called. So if someone were to ask you, what is the bond between monosaccharides, two monosaccharide monomers, you wouldn't say just covalent, you'd specify it's a glycosidic linkage, and that implies that it is covalent. So with respect to building a monomer, a polymer, we've already discussed that it's comprised of a monomer plus a monomer plus a monomer, and so on. And that monomers are linked via covalent bonds. This is only possible through either a condensation reaction or dehydration synthesis. A lot of people use the words interchangeably, but that's not necessarily the case. They both involve the loss of a small molecule, but a dehydration synthesis reaction solely refers if that small molecule lost is water, hence the dehydration in the name. They both involve the loss of a small molecule. Dehydration just refers to that molecule being lost as water. So below we have a general overview of how the process works. So to the left you can see that a short polymer has already been constructed and it's in the process of elongating. So that means we're adding more monomers to make the polymer longer. To the right we see an unlinked monomer. It's not numbered yet because it's not part of the polymer, just a monomer on its own. We see that water is leaving, it's being taken out, so that means it's a dehydration synthesis reaction. We're losing water. That is our small molecule that is being lost. Because the water leaves, that allows the unlinked monomer to covalently bond to monomer 3, which is already part of a polymer, and they join via a covalent bond. We don't know what kind of macromolecule it is, so we don't need to specify the type of covalent bond. For now, we'll just say covalent bond. So for a lot of people, this little diagram sparks some confusion as people wonder, where does this water come from? Well, let's take a closer look. So for example, we have carbohydrate monosaccharides of glucose. So glucose is our monomer. As you can see, we have two monomers, and then we see the OH from the monomer on the left and the H from the monomer on the right. They come together to make a water molecule. And then that is what allows the two glucose monomers to link and create maltose. And this linkage is called a glycosidic linkage. I will be having future videos discussing each of the macromolecules in depth, but this is just a general overview so you can kind of get a sense where this water is coming from. So see here, that's where that water is coming from, the structure of the monomer. And then with respect to amino acid monomers, here's just another example. See right here, we're losing a water molecule. But we're forming a water molecule and it's being taken out, and this loss is what creates the conditions for the two monomers to join together. And here, this covalent bond is called a peptide linkage or a peptide bond. Now, if we want to break down a peptide into monomers, rather building monomers into polymers, we use a reaction called hydrolysis. I like to break down the word itself. Hydro means water, and lysis means splitting. We add a water to split the molecule. As you see here, water is being inserted between monomer 3 and monomer 4. This causes the covalent bond to break, and now the monomer 4 is on its own, and then we have a polymer still present to the left, but if we wanted to break down that polymer into its respective monomers, water would be added between monomer 2 and monomer 3, and monomer 1 and monomer 2. And then just to tie it all together, there are four major classes of macromolecules: carbohydrates, lipids, proteins, and nucleic acids. As mentioned before, they're all different, but with respect to their synthesis and breakdown, they follow the same mechanisms, which is synthesis, dehydration synthesis or condensation reaction, and then breakdown, hydrolysis. And, different terminology is associated with each class of macromolecules. However, this is just a general overview. I will be adding videos to this series, going in depth with each respective class. I just didn't want to bombard you with a whole bunch of information at once. But I hope this helped clear up any confusion and provided just a solid general understanding of what's going on before we go into more detail. So stay tuned, and thank you